Hello friends, yeah, here we're going to find out the limit of this question. Here question is limit x tends to 0 cosec x minus cot x whole divided by x, right? And in this present time, if you just plug the value of x tends to 0, then you're going to get cosec 0, right? You'll get cosec 0 minus cot 0 and whole divided by 0. Again, see what you're going to get. In the denominator, you're going to get the 0. And whenever you get anything in denominator 0, somehow 0, then that time that the whole quantity will be undetermined value, undeterminate value, right? You cannot determine. So this is not the way to do. If you further do, it will be like this, and you cannot evaluate the limit of this trigonometric expression in that way, right? So we need to apply some kinds of trigonometric operations, and after doing those operations we should get our denominator not in the form of 0, right? We should not get any time, we should not get our expression as a 0 in the denominator. So what we can do further, yes, as we used to do in the trigonometry, that we used to convert all the things other than sine and cos into the form of sine and cos. Like we used to convert tan, cot, cosec, right, sec, everything we used to convert into the form of sine and cosine, and that makes really easier to us to solve the problem. So same thing I'm going to do here. Limit x tends to 0. Here I'm going to convert this cosec x and cot x in the form of sine, and cosec x, we know everybody, that is 1 over sin x, and here cot x is equal with cos x over the sin x, right? And then whole divided by this x. And now in next step, limit when x tends to 0. Now sin x and sin x will be common, I mean LCM we can take, and you'll get here sin x, and this will be left with 1, and this will be left with cos x, right? And then whole divided by this x. Okay, and now in next step, limit x tends to 0. Now see here 1 minus cos x, and this sin x I can bring downstairs in the denominator because this one is the bigger one, right? Now, so it is now 1 minus cos x whole divided by this x, right? This x times this sin x is coming downstairs now, so this will be sin x. Now let's check, still we are getting our denominator as a 0 or not. Yes, when x tends to 0, this x will be 0, and in the denominator we are again going to get the 0, that is again undeterminate value. So again we need to do some further trigonometric operations. So now what we can do, let's think. Yeah, we can convert this x as a half angle, right? And let me tell you here that cos 2 theta is equal with 1 minus 2 sine square theta, right? This formula you have learned in the trigonometry. I know you're very good with this, very good, well known with this formula. So same thing I'm writing here. If it is cos x, then what can I do? I can write here 1 minus 2 sine square x over 2. When there is double of the theta, there is single theta, and when there is x, there should be x by 2, right? This is half, this theta is half of the 2 theta, and here x by 2 or half of x is just half of this, you know, I mean x by 2, you understand this, that's it, right? So same thing I'm going to put it here. So now it will be limit when x tends to 0, right? 1 minus, right, in the place of this cos x I'm going to put this value, I'm going to use now 1 minus 2 sine square x over 2, right? And now in the denominator we have x times sine x, and we know that sine 2 theta is equal with 2 sine theta times cos theta. So if there is sine x, then we can easily write 2 sine x by 2 cos x by 2, because here when there is 2 theta, there is theta, so when there is x, there should be x by 2, right? So same thing I'm now going to use here. So my x is as it is, this x, and in the place of this sine x I'm going to use this value, right? That is 2 sine x by 2 times cos x by 2, right? So let's go further. Again here, limit when x tends to 0. Now see, this will be 1 minus this 1, and then minus times minus, it will be plus 2 sine square x by 2, and then whole divided by this x as it is, and this is 2 here, then times sine x by 2 times cos x by 2. So now see, what are the things going to be cancelled out here? Yes, this plus 1 and this minus 1 will cancel out, and this 2 in the denominator and numerator will cancel out. Now after cutting this, you can cut it, right? And here this is square of the sine x by 2, means there are 2 sine x by 2. It means actually sine x by 2 times sine x by 2. So I can cut 1 sine x by 2 with this one, right? I mean to say, this will be cancelled out, and here we'll be left with sine x by 2, right? And finally we're going to get limit when x tends to 0. There is nothing in numerator, there is only sine x by 2, 1 sine x by 2, because 1 was cancelled out with this, so 1 sine x by 2 is left. So I'm writing here 1 sine x by 2 whole divided by this x is here, and then times cos x by 2, cos x by 2. Yes, I'm seeing something very good result here. See here, sine x by 2 over cos x by 2. I think this formula is hitting in your mind. Sine theta over cos theta is equal with tan theta. So same thing, I'm going to use it here now. Now see here, limit when x tends to 0. Now sine x by 2 over cos x by 2, that is tan x by 2, and then whole divided by this is only one x left here, so I'm writing here x. And now see here what I mean to say exactly, because from many videos we are writing this formula that I'm going to use here, that is limit, right, when angle tends to 0, tan of the angle over the angle is equal with 1. Please keep this formula every time in your mind while when you are solving or finding limit of the trigonometric expressions of some functions, right? So here what you can see, if angle is here, means when angle tends to 0, tan angle over the angle is equal with 1. So here my angle is x by 2, right? But here is not x by 2. So what I can do here, I can divide by the 2, and again I can multiply by the 2. And now see, sine angle over the angle. And again I want to tell you here that when angle x tends to 0, definitely half of that angle also tends to 0. You got it? You understand? Yep. Now in the next step, what I'm going to do here, this is almost the final step, limit. Now in the place of x tends to 0, I can easily write half of x tends to 0 and tan x by 2 over the x by 2, and this is 2, right? So I'm writing this 2 a little bit away, right? And now here what I can use, this is my formula actually. Just match this formula with this one, right? When limit angle tends to 0, tan angle over the angle equals to 1. So here when limit angle is what, my angle is x by 2, when my angle tends to 0, tan of the angle over the angle tends to 1. So in the place I can easily write with no doubt that this is 1 times 1 by 2, and finally my answer is half. That's my answer. So this is the limit that I need to find out from here, right? And now see, we find out here, and from this problem as we solve here, so what do you understand, that to find out the limit in calculus chapter, you must be good in trigonometry also. So please, once again I'm telling you, I'm requesting you, go to the chapter of trigonometry and learn each and every formula and tricks how to solve the trigonometric expressions, and how to get actually, finally what you need to do. Anyhow, whatever the operations you do in the denominator, you should not get 0. Do all the operations what you know, but your denominator should not be 0. And once you get denominator not as a 0, you can directly plug the limiting value and you'll get the answers. Alright, so we'll be meeting in the next video with a little bit difficult problem. Bye bye, and please don't forget to subscribe me. All right, bye bye.